The impact that ended the dinosaurs. And what if it happened today? 66 million years ago, Earth experienced one of the most catastrophic events in its history. A massive asteroid, estimated to be 10 to 15 kilometers wide, crashed into what is now the Yucatán Peninsula in Mexico, forming the Chicxulub crater. The impact released an unimaginable amount of energy, triggering wildfires that spread across continents, sending tsunamis racing through the oceans, and filling the atmosphere with dust and debris. The sky darkened, blocking out sunlight for months or even years, leading to a dramatic drop in global temperatures. This period of extreme cold and darkness, known as an impact winter, caused the extinction of nearly 75% of all species, including the dinosaurs. Could we stop a similar asteroid today? If an asteroid of similar size were detected heading toward Earth, scientists would race against time to stop it. NASA and other space agencies constantly monitor the skies, tracking thousands of near-Earth objects. If the asteroid were detected years or even decades in advance, we might have a chance to deflect it. One possible method would be sending a spacecraft to crash into it, slightly altering its trajectory. This concept was successfully tested in 2022 with NASA's DART mission, which changed the orbit of a small asteroid by direct impact. Another approach could involve using a spacecraft as a gravity tractor, hovering near the asteroid and slowly pulling it off course using its gravitational influence. In extreme cases, nuclear detonations could be considered, not to destroy the asteroid, but to push it onto a safer path. However, if the asteroid were discovered too late, only months or weeks before impact, our options would be severely limited. A large enough asteroid moving at tens of kilometers per second would be nearly impossible to destroy or deflect in such a short time. In that case, all we could do is prepare for the inevitable. If a 10 to 15 kilometer wide asteroid were to strike Earth today, the consequences would be devastating. The impact would release energy equivalent to billions of nuclear bombs, instantly vaporizing everything within hundreds of kilometers. A massive fireball would spread outward, igniting forests and cities. The shockwave would flatten buildings and send hurricane-force winds across continents. A massive tsunami could sweep away coastal urban areas. The blast would eject trillions of tons of dust and debris into the atmosphere, blocking out sunlight and plunging the planet into darkness. Crops would fail, temperatures would plummet, and global ecosystems would collapse. It would be a repeat of the dinosaur extinction, but this time, humans would be the ones struggling to survive. In the aftermath, only those who managed to seek shelter underground or in well-prepared bunkers would have a chance of survival. Governments and private organizations have built underground facilities, but they are designed for temporary disasters, not years of global winter. Food supplies would become scarce, and without sunlight, agriculture would fail. Societies would collapse as desperate survivors fought for resources. Some small pockets of humanity might endure, especially in protected environments or underground cities, but civilization as we know it would be gone. Over generations, if the planet eventually recovered, the survivors might emerge to rebuild, much like life did after the dinosaur extinction. But it would take thousands, if not millions of years for Earth to fully heal. The idea of an asteroid impact wiping out human civilization is not just science fiction, it is a real threat. The difference between us and the dinosaurs is that we have the technology to detect and potentially prevent such a disaster. Whether we act in time is another question entirely. If you watch this far, I would really appreciate it if you subscribe to my channel and like the video.